Okay, good evening, everyone. Thank you, Yuri, for beautiful introduction. My name is Yash Madhwal, and first of all, I would like to thank everyone who has joined online and offline for listening to my seminar. The seminar today is going to be about integration of computer vision with blockchain and to improve supply chain management and product authentication. Apologize for my little voice. I think this climate change has affected me a bit, but I think I will be healthy enough to present the seminar for today. So a little bit about myself. I don't have a slide on it. I am a research scientist here at Skolkovo Institute of Science and Technology, Skoltech in short, and down there you can see my email ID. My research work when I was doing PhD was more aligned towards blockchain-based applications, specifically towards the direction of supply chain management. During the course of the PhD studies, I have mainly aligned my work on supply chain domain and published a lot of work around it. Right now, like when we have met in previous seminars, I have more or less talked about the supply chain itself. And this is just an extension of the previous work that I have been doing here and also that I have presented in this in this journey of the seminar of my previous talks. So little bit, as you know, blockchain. Oh, excuse me. Okay, there we go. So, so first of all, I would like to tell this seminar is definitely is going to be beyond finance. We will be talking about supply chain. Initially, when, as you know, like when the idea of blockchain and Bitcoin came into existence, it was aligned towards more of like financial domain, but nothing against that. It is just like my interest to show you how supply chain can also go, blockchain can be used beyond finance to different domains like supply chain particularly. So as we see on the screen that a product journey usually goes from raw material to consumer, and it goes through lots of different phases, different changes, different entities, different conversions that takes into place, and in the end finally ends up to the end user. So if we talk about problems in this domain, so there are lots of problems that are there, still there, and was there. So major problem being like tracking, like tracking the product from its origin and so on. There does not exist transparency. There does not. There is a lot of corruption practices, like corruption in terms of not in terms of money, but it also in terms of like safety standards, for sure money. Because of these things, it is very expensive for the company because lots of time is used. And because of some human error, there are also existing problems. And with the potential of blockchain integration, definitely you can mitigate these problems. Like using blockchain, you can do tracking, tracing, control supply chain, you can get the source of origin. Also, you can check the availability of the information because as you know, like blockchain is tamper-proof and so on. But blockchain and supply chain is not new anymore, and these problems will be there, and there are many proposed solutions that are already existing around blockchain with the use of supply chain. And if you see in the Google Scholar, like you can see approximately 344,000 research that have been already done on this area. So what exactly new we are going to present this thing? We are just going to this time make an extension that apart from only talking about blockchain and supply chain, which talks about problems and solutions, proposing different methods, like how beyond this thing, what things have gone around and how problems can be more defined specifically and how it can be mitigated. That is the overall idea of the presentation. So in general, when we talk about blockchain, definitely we are talking about tracking and tracing, but practically these things are much in easy sense done by using smart contracts. And a brief introduction of what exactly smart contracts are. As you know, it's like a self-executing programs which has predefined rules, and automatically it is done when some rules are fulfilled and executed. So a basic workflow is like, excuse me, basic workflow is like conditions are defined, conditions are met, specific actions are triggered based on the conditions that were defined. A very simple example, if we talk about finance, will be like transferring of funds or like updating record, for example. So what exactly if we try to relate the supply chain workflow might look like based on smart contracts. So if you see take a very generic workflow where there is a product that goes from supplier to the client or like end user. So a basic setup of this thing will be like there will be an agreement between the participants, which will define, for example, product details, terms of payments, delivery deadlines, and penalties. And if you define all these things in a smart contract, and if the conditions are met, the funds can be transferred easily. And if some terms are violated, like some conditions are not met, you can impose fines or like trigger some penalty and so on. So like it's all depends on the workflow that you plan to implement on. Okay, so generically, in general sense, how exactly smart contract interaction works. So smart contract interaction, mainly if we talk about like usage, in sense, like if you are keen on doing some, let's say, some payment transactions. So most likely, and I think in my opinion, the most popular way is to do through a browser. Majority of blockchain known users, they might be using a wallet-based extension, browser-based extension wallet, for example, MetaMask in our case. So to interact with an application, like we call it decentralized application or DApp, if we talk about blockchain domain, you will be an actor who will interact with application through your browser, and this browser will have an extension like MetaMask, for example, that you have on your screen. And to make a transaction not in terms of money transaction, but just to do some action on the blockchain, you should manually press the button, confirm on it, then and only then, assuming all the parameters are fine, all the data that is going to be processed on the blockchain is correct, the transaction confirmation will happen without any problems. So this is just a generic workflow of how smart contract interaction works, despite of any domain like finance, supply chain, healthcare, for example. This is just a basic workflow of how the transaction interaction can be done on the blockchain through your browser or like while interacting through to a decentralized application. Right. So what are the... Okay, I messed up the slide. So during this case, here you see, like I said, whenever you are doing this action, you should do a manual confirmation. That means you should move your hand with the mouse, let's say, and press the button confirm over here. So what are the potential solutions that you want to automate? So for example, you have a browser and you want to do this thing kind of automatically. So for example, you are a very busy person and you don't want to spend much time in front of computer, that you wait for some transaction to process manually. So what you can do, well, this is not a tested method, but this is my assumption. This is what you can do. Number one is to use Selenium-based Python library. I don't have experience to do it for blockchain interactions, but I do have little experience to do for automation work. You can use maybe this thing, or you can do some other library-based work to do this thing automatically, where you can do the transaction on the blockchain automatically. So what problems are usually there that you can face? Like number one, you are doing automated, and what problems you can face that while doing this action, the interface might ask you like if you are a robot or not. And maybe, okay, there are ways, but probably I'm assuming this I am not a robot thing you cannot pass easily. And secondly, excuse me, and secondly, when you try when you try to do this manual work, and if you are a person who's sitting and doing this manual input to the blockchain itself, you might be overtime working, who knows? You might not have a good sleep last night, and like who knows, like you might make a mistake while putting some information manually in the system. So these are some potential problems that can appear, like number one, bypassing the automation gateway, like can ask a computer browser can ask like you're not a robot to pass that thing. And second, like you can manually by mistake, unintentionally make some mistake by inputting wrong information in the system. So what can happen? Yeah, so like it is incompatible with the basic interface, can possess a security risk, and definitely it gives you a value error for your mistakes in general. So in the previous talk, also in this seminar, we presented something known as DOIT. It is known as decentralized IoT, where we kind of eliminate the intermediaries and directly have a device and the blockchain that are communicating with each other. So what are some basic advantages of it? So there is a direct blockchain-based interaction via the smart contract. So there is autonomous transaction signing. It is definitely secure. I'll come to it how, and like it is decentralized architecture for you. So like that is why we call it a decentralized IoT. Okay, so why was it required? So we feel the requirement of this DOIT is that manual processing, like if you're actually manually putting some information, manually putting information can be termed in terms of like, for example, if you are going to update a status of product which is in the origin, like weight, temperature, and so on, you can manually make a mistake. Maybe instead of 96, you put 98 by mistake. I mean, it's human error that can definitely happen. So initially, the IoT infrastructure that were existing, so there are more like centralized, like there is a center point of failure. If the center one fails, the whole system is failing. And real-time responsiveness is essential. That means IoT system is on real time communicating with the blockchain, because real time in sense like you cannot expect IoT to hold the data and wait for you till you come and press manually transaction approve, something like that. So that is why it was required in general. So the use case of this thing can be something like this, where IoT device is fit inside the truck, and this truck is constantly communicating with the blockchain to monitor the temperature. And well, the question might arise, does this infrastructure controls the fridge? Well, technically not. The idea of this design is that if there is a deviation from the required temperature range, and if it is recorded on the blockchain and that recording is irreversible and it will be permanently recorded on it, technically when the product will reach to the user, they will, or like a quality control, they might know that where the deviation happened, by how much, and so on. So this device is a very basic setup of Raspberry Pi, along with Arduino and lots of some LEDs to show some basic demonstration of how it can work. So the figure on your down right is like sensor connected to Arduino, then Raspberry Pi, and the blockchain. So giving an example of the use case example. So if you were wanting to transport the cream cheese from east to west coast, where specifically? I think it's between New York and Los Angeles. So this cream cheese, if it goes beyond some temperature, I think I have not written it. If it goes beyond this temperature, it gets bad instantly. Well, okay. So if you are crossing across the states, and this is the idea, like where such type of device can be useful to track if something went beyond the range or not. Yeah, so we had for this first level user interface where you can do some granting access to a specific device, because not all devices can have access to do this work. So that is why you give access to some particular device. Each device is integrated with a private key, which can interact with blockchain after doing some automatic signing and so on. And then definitely you can have, for example, on the screen product ID 3, there you can see some like danger zone like red, it went beyond, and so on. Just a simple use case of how the user interface can use this decentralized IoT architecture, and like how user can use it. This is just an idea to show. So disadvantage overall of using this decentralized IoT is that number one, fund monitoring. So depending on the use case, if your device is continuously, let's say every 20 seconds on safer side, let's say if we talk about Ethereum, on every 20 seconds if it is communicating with the blockchain. Yeah, so let's say after every 20 seconds it is making this transaction. And if we are talking about traveling from east to west coast of United States, then definitely we are talking about like 20 seconds for 6 days, a quite number of time, quite long amount of time. And during this time, there is a high probability, well, not exactly high probability, there is a high probability of a situation where you might not be aware of how much funds is left in a particular device. Okay, you might have a user interface, but if we are talking about a lot of devices, that time might be difficult to track. And this device is continuously communicating with blockchain. So definitely to run the blockchain system, you need to spend the gas, not the transport gas, but blockchain experts, you all might be knowing this fees that you should be spending on. Okay, so the problem that comes is the fund monitoring. So you might go out of funds and your device technically is not offline, but it becomes not usable. So that is a disadvantage of here, and that leads to out of gas failure because there was no money to pay for the system. So it automatically did not become offline, but became kind of useless, not exactly useless, like not usable, I think is more respectable term for this. So we added in the next study a layer of gasless transaction. So in brief, it talks about ERC 4337, about account abstraction using alternate mempool. So long story short, it's talks about gasless transaction, meaning that the user itself does not pay for the gas, but gas directly, but rather it uses a third party, I'll come to it, third party system who will manage the gas for you, and usually like a paymaster is what is used in the system. Some overview of account abstraction. It's like a powerful Ethereum upgrade that allows smart contract to act as wallets, enables custom rule for transaction verification, supports metadata, example, gasless transaction user action, and removes the dependencies on normal Ethereum externally owned accounts. Okay, so basic workflow looks like this. So you have user operation, bundlers, entry point, smart accounts, paymaster, aggregator. But to come and put things in simple ways, so you as a user, well, a device as a user will sign a transaction, signs a transaction. There is a paymaster which is already funded with lots of, let's say, safe term, with lots of native tokens, and there is an entry point contract which executes a transaction, and despite of having zero balance, you can simply do a transaction on the blockchain using this infrastructure. So for the experiment, we used Konami as a paymaster. We funded it with, I think, like 2 to 3 test tokens, and we did experiment on top of it, and everything was fine. So we compared two types of workflow. Number one, we used regular transaction workflow, and secondly, we used gasless transaction, that is account-based transaction workflow. And this workflow was done. In regular one, we funded each and every token, each and every device with some 0.1 test Binance. We did it on Binance test chain. And in gasless transaction, we funded the paymaster with 2 BNB to cover all the transaction cost. And based on the exact similar workflow using regular transaction and gasless transaction, we had this output. Now here you can see the gasless transaction technically spent less amount of gas comparing the gas transaction technically spent less amount of gas, whereas the gasless transaction using the paymaster comparatively spent more. The question might arise that is it like a double or like this is the fixed difference? Unfortunately, I might not answer this question at this point because we might need to expand our test input to see exactly like this difference of this difference is fixed or like is it like a double or not. This I might not answer at this point. So yes, similarly to extend, like this is again was a use case where we talk about this IoT device plus supply chain, and this was a very simple mobile based application infrastructure that you can see on your screen, like different type of screens. So there's a transporter, receiver, what else? To check the balance and some status of the device itself, and so on. So like this is what all you can do. So in summary, so we successfully made this IoT device. We used Bioeconomy Paymaster to let IoT interact with blockchain without paying any gas fees. And this was processed on the real-time simulated supply chain. So everything worked fine. If you want to read more, here are some links. You can definitely look into it. This is already published work. So yeah, if you want, you can, after this lecture, the slide will be shared. You can definitely read more into it in details. So a bit of a recap. What we have discussed so far, we have discussed like when IoT meets blockchain, how they met. And we also discussed about the gasless transaction, that how it can be incorporated with IoT and the blockchain itself. And now what happens? And now we introduce a new thing, which is OpenCV, a camera module. This work was done with the students who are also here, present today with us. So yes, we added now an new module to this IoT device, which is a camera module. And we used Python scripts like library OpenCV. And we did a lot of things. Let's discuss in the further slides. So what was the motivation, like, to why did we decide to add this thing? The main idea was that we wanted to perform supply chain product authentication. Even though like you have a device itself, I understand the things can be done, but it is just an add-on, like how a supply chain, in terms, if we talk about assembly line, can be used using camera module and then interact with blockchain to sort things out in simply. So basically, it's an implementation of prototype with, excuse me, IoT device with a camera. And overall, we did simulation, we have a dashboard that's being used. And during this phase, we also learned that what problems we saw while doing this design and how we optimized it and so on. Let's check in the further slides. So this components uses three main things. You have Arduino itself, which is connected to a camera module. And then these two components are connected together to the Raspberry Pi. So at the add-on stage, initially we connected the camera with the Arduino module. Data pins were connected, and we had to use some resistors to balance the input and output of the camera with the Arduino. And there we saw a problem that it was taking a 4.5 seconds of delay while reading a picture. So on the right side of the screen, the challenge was to synchronize this camera with the output with the Python script. So the optimization method that we used itself for the device was we switched the libraries. On your screen you can read, and we changed some parameters. We reduced the size of the QR code and so on, so that eventually we were able to get a high resolution pictures. And when we integrated Raspberry Pi itself, everything was more or less fixed for us. And finally, this is what we got. We had a device, the whole device itself. This is what you got. Now, if we look inside this device more from the programming perspective, we did 3 steps to get the clear image. Number 1 was to pre-process the image, most important step, and then write the script to detect, scan, and decode, obviously, the QR code itself. And once you decode all this information, you need to interact with blockchain itself to write information on it or to get information from it. So first of all, to pre-process the image, the main steps that we use, first thing was to convert this image into black and white. Then upscale using cubic interpolation. This means like to make the edges of this QR code more sharp, and then apply Gaussian blur so that you have a little bit more clear image. After doing this thing, we did not face much problem to get the information from, yeah. So as a result, the image became much ready to read the QR code for scanning and decoding the information from it. And then the device itself was coded using Python. We used OpenCV library because it had the pre-built library to read QR code. It had all this intermediate steps of image processing. It was easy to integrate, and it's on Python based, and we were using the Python itself to do interaction with the blockchain. So, everything went hand in hand, and definitely this library is free to use. That was also a big motivation. Okay, once we did these two steps, the third step was to interact with the blockchain itself through the smart contract. And here you can see that on the screen on the right side, you can see we scanned the QR code, and this QR code gave the corresponding response of the sender and receiver. The sender and receiver, here we talk about the device itself, who was sending and who were responsible to scan and send, and scan and receive. And that further updated the product ID on the blockchain. So we did little bit of real-time simulation that when, for example, a conveyor belt which has a product and scanned QR code, and if it is moving, will it be able to scan or not? So this is what we tested. We rotated it, we moved it, and we used phone printouts to show that if everything is readable or not. And if there is good lighting and all, it is readable, but in dark, unfortunately, it's not readable. Maybe with the night vision camera you can do it, but that thing we did not test it as of now. And now the smart contract itself. So I have been talking about interaction of IoT with smart contract, but the smart contract itself was looking like this. That was coded using Solidity and deployed, and we used Hard Hat framework to do all the testing of smart contract and so on. So if we talk about the actors of the system, you have the owner, you have the label creator, you have IoT sender and IoT receiver. And the last point, like we were limited with the device in sense like we had only one physical device with us at the time of this work. So we were switching the role of one device itself into actor into sender and receiver. Like the one device was working as both sender and receiver at the same time. Now we have more devices, and definitely this work can be split into multiple devices. That's for, I think, future use case to be done. So a basic smart contract idea look like this. So there is a shipment cycle. So there is a register, like you need to register a label with the system. And when you dispatch the label, assume it is ticked on a product, the IoT sender, the IoT device, which is acting like a sender, will scan the QR code and dispatch and mark the status on the blockchain as sent. When we talk about delivery, there is another IoT device at the delivery part. When this same product with the QR code, let's assume, with the corresponding ID, comes to the receiver, the IoT device reads the QR code and automatically writes on the blockchain. If something is, let's say, damaged, the product can check if it is damaged or not and can reject the device itself. And all these events that are happening on the blockchain, it is emitted via the smart contract. So for simple words, this is a user interface that was used. So there is a list of devices that you can see, which has role of either sender receiver, like technically we have one device, but this is just a testing scenario that we used for. And if you click view device, definitely you can see the more information of the device itself in the later slide I'll show. What else? Here, yeah. So here is the metadata of the device itself, and the related products part, which is down, is the corresponding actions of product IDs that was done using this device. Once the admin generates a QR code, this QR code is generated from the blockchain. You can print out and stick it on the system, and then you can use it for sending or receiving by scanning the device itself from the IoT device. You can also add device, you can also remove device. This thing is an add-on feature that you can do. Then definitely all the product list that you have done on the system, you can from the dashboard can view like using send, receive and void. I think this front end was developed using Flask, and yeah, this is how the actions were being performed over there. I think, yeah, this is about the device itself. No. This is the product information, that who was the sender address, from what device was it sent, and what device scanned it to receive it. And okay, receiver address, at what device will scan it to receive it. So at the moment it has been sent but not received. So only when the receiver address, when the device which correspond to this receiver address is authorized to receive it, this is one of the important point and feature. Only like this device itself is authorized to receive it, and if it matches this parameters, it will be marked as received as yes. Okay, so for the experiment setup, we wanted to check if everything works fine or not. We evaluated the smart contract. So first of all, sure, we wrote everything in hard hat. We deployed on the local network, and we used Web3 Pi to interact with the blockchain to see how much gas we consumed. So we did some simulated design, just for simple terms, where we took a string from this much length, 10 to the power 6 to 10 to the power 20. The reason was of this string length was to mimic, because it mimics the realistic and extreme identifier ranges we got from internet, the usual range. And then we checked how much money it's, well, gas in terms spent to create, label, mark as sent and mark as receive. So this is what you get actually. Create label was taking a lot of time, and if you see that there is a jump over there, it's because that it is using a new memory space. And interestingly, like why after a jump there is a drop, apparently the reason is that even though there is a jump, it allocates a new memory space, but for somewhere, I don't know at what upgrade, it kinds of refund also. So that is why you see a jump and a drop in a specific pattern, because where it allocates new memory and also refunds some memory space back to the previous one. This is information I found on the internet, like why we get this thing. So in a short conclusion, so this work was a demonstration of working prototype of IoT, computer vision and blockchain. Definitely this can be integrated with the gasless transactions, which we do not do at this stage. We had a role-based smart contract to ensure secure and tamper-resistant shipments. And in short, like it is definitely scalable for a bigger development if you require. So where can we go from this point? At this point, like the figure on your right, you can see that instead of actually printing the QR code itself, well, this slide talks about the industrial implementation. Instead of actually printing the QR code, if you have machines, you can actually engrave this thing on a piece of metal. And this piece of metal, as per our testing, was fine in terms of the size of QR code that we generated it. It was completely fine to be read from the device. Apart from generating QR code and writing this information on the blockchain, we can definitely store a corresponding certificate of the device itself, which will be generated from the system. Certificate in terms of like certification of the authenticity of the product. This can be done. And we have a paper under review around this thing, which talks about not exactly access control itself, but it's more about gas efficient IPFS URI management that we talk about. Further on, we have another kind of related work which talks about industrial implementation of decentralized oil extraction infrastructure via blockchain-enabled IoT networks, which is also under review. And here the scalable part is that here we do not talk about one sensor itself, but we talk about up to 14 sensors which can be integrated. And definitely it also has a blockchain-based storage. And I think once it gets accepted, probably in the future talks, I can come again to talk about those things in more in detail. So that's it from my presentation. Apologizes for my voice a little bit. I'm having a little difficulty to speak also. So that's it from my side. I'm open for your questions. Please, looking forward for your questions. Thank you.
Now we use this microphone.
Yes. So let me answer the first question. Like Anton asked, why do you need Arduino in this project as middleware between Raspberry Pi and camera? I think RP is enough. Raspberry Pi is enough. Anton, thank you for your question, first of all. And we definitely agree with you. Raspberry Pi is enough to directly have camera integrated with Raspberry Pi is enough to directly integrate camera with the Raspberry Pi itself. And this is what we have planned, like in the next iteration of this research, to remove Arduino, because we will be focusing more exactly on other use case, and this time for easy reading of QR codes, maybe small QR codes. So we will be eliminating Arduino for the next iteration of this work. So yes, this was the previous work when we were in the still initial stage of this. And by the end of this work, we realized that Arduino was actually not required for them. Yeah, so that's why for the next iteration, we are removing Arduino.
But why in this pipeline Arduino may be helpful? Maybe for some analog signals?
Yes, Arduino was useful initially, like, actually, there are multiple components that we have. So we have blockchain interaction, we have Arduino and camera, which can work separately for different use cases. But when we wanted to combine all these things, interact with blockchain, have camera read through Arduino and all, that time I think we did not think much initially that we could optimize it. So this is why we used Arduino itself to have first camera read through Arduino, and then process then signal sent to Raspberry Pi to do the further action.
Thank you. Any other questions?
I have questions. What should tokenomics look like in this setup so you don't run out of gas tokens?
Yeah, what should tokenomics look like? So, well, as per the second research technically of the first part, you should fund paymaster with good amount, and probably make a separate research that how much time it takes that you can actually run out of some amount that you will fund. And probably based on that, you should define that for how much time you are sufficient enough to run without running out of all the tokens.
Token distribution in airdrop, like airdrop.
I didn't quite get this question. Token distribution there.
So probably I need additional tokens for new transaction, and where I keep new tokens for gas.
Okay, for new tokens of gas, if you talk about, let me try to switch this quite far back, but let me just try to switch it back for you. Okay, if we talk about the tokens where it should be sent, so we are sending to a paymaster. You technically send to paymaster directly, let's say 5 test Ethereums, and then using something around smart contract, you enable that this address, and this address will be used using your paymaster to do spending on the smart contract.
Thanks.
Yeah, this tokenomics, only this much I can tell you. Like you fund one amount, you technically don't distribute, but definitely amount of usage that will be there by individual address, that might differ. One account might be using lots of transaction comparing second account, so might be the distribution might be like this, but I think overall paymaster is like a third person who's doing work for you, in my opinion.
Anton Ledrov continues. Am I understand right that the idea is to use blockchain and IoT pipeline only as the advanced and more secure login?
Anton, if you can define it, what do you mean by secure login? Let me think till then, like what exactly you are trying to ask.
Maybe previous question. So yeah, so I guess most likely it is assumed that in production such systems will work in private environments, not in public, and gas is used rather as just measure to prevent DOS, and generally we do not need to pay for tokens. We just need to have a source of tokens. Am I right?
So yes, you are right. Like first part for sure, like definitely this stuff this type of use case will be definitely be used in more like a private enterprise level of adoption. They will not be using public blockchain. And you can hear me recall the second part of this question.
So gas is used only just to prevent some DOS attacks, and we will just have some free flow of tokens.
Yes, for the free flow of tokens, probably for DOS attack, but I think that was not my main criteria of using it. Yes, to have free flow of token without any interruption to your use case, like if you're continuously interacting with blockchain, just to have a free flow workflow to have this thing. That is why we are using a third-party base to fund the system.
Gas is traced just for performance measurements.
Yeah, but for performance measurements, yes.
Okay.
Yes.
Anton extends his question to log some information in more secure way, so that the information cannot be changed or forged.
Okay, then let me recall my understanding. The idea is to use.
Why IoT and blockchain? Why blockchain in IoT pipeline?
I mean, for sure, like to give a generic answer, to have information stored in a more secure way, but how to do that thing, that is where we differ, that the IoT device itself is automatically interacting with the blockchain to have information stored in a more secure way. That's the first part of your answer. So that the information cannot be changed or forged. Yes. If we take the first example, that is the main use case of why, first example only, why this IoT device is interacting with blockchain to store it on chain. Yes, that is the reason. But the second part also does, third part technically, when we talk about cameras, it is also doing the same thing. But here the idea is that the sensing factor that the transaction should be triggered is using the camera. So camera reads the QR code, it checks information with the blockchain, and if the information matches with the blockchain, it does the next action of marking the product on the blockchain. So yes, first example is to store information directly on the blockchain so that it cannot be forged. Technically, the third example where we talk about the cameras, it's about checking the stored information from the blockchain and then doing the actions based on the information it matches from the blockchain or not. I hope I answered your question. You're welcome. So just like further plans for this thing is to definitely, we have a personal use case that is lined up with us. We look forward to implement this proposed architecture to that use case, and definitely to extend this work, probably using this workflow in more private permission blockchain, let's say. That's our next plan of action to be done.
And one more thing, why should IoT devices be a part of the blockchain in this case? Why can't we just send all the information to managers and then managers push it to the blockchain?
Okay, if we talk about managers, are we talking about human managers or we are talking about the device manager?
Well, it depends, some manager.
Okay, let's talk about human manager first. Human manager is loaded with lots of information to read and write. And I think that was one of the motivation statement that I gave, that because of so much information to process, he might be tired, sick, and might be making a mistake to put this information.
But just some server to sign transactions for us to make more lightweight computations on IoT device and be happy.
Okay, and then there was a slide, why do we need this infrastructure? Because that will make it to a centralized point of attack, and if that centralized server is failed, your whole IoT infrastructure is not exactly failed, but like paused for some time.
But now keys may be compromised, as far as I understand.
Keys might be compromised, so there are definite. Okay, right now we did not take this consideration of attacking the keys for sure, but definitely there are more ways and better ways to store the keys in the system, and I think that can be implemented, like to store maybe key sharing. Who knows? I mean, there are ways to do it. Just like as of now, as per this stage, we did not implement such. We just kept everything simple, that keys are not getting attacked as of now.
Thank you.
That was very, you're welcome.
Any other questions? maybe about plans, some plans for integration you've mentioned, but maybe you are interested in collaborations with colleagues or young colleagues, students. It's just the beginning of the academic year. So are you open for collaboration?
Yeah, sure, I'm open for collaborations. So there is a plan that should be done, and definitely looking forward if somebody can help us to fulfill that plan. So I think I wouldn't, for some reasons, not like to disclose much in details about it as of now. But yeah, so this is just still research work. So we definitely look forward to expand, integrate to more industrial-based workflow. That's our plan of action to be done. And like I said, we are still talking about not only implementation, but also designing the architecture, because if we scale up this work, definitely this work is not limited to only a single person or like team as us who is implementing for every full business case, but definitely need to take other considerations like how to scale up, how much input of information will be there, the workflow. So yeah, definitely we will look forward for some helpful collaborations who can help us to scale up this work if we get a successful opportunity to implement it for a real business case. Yes.
Thank you. And you've mentioned that in some cases Raspberry Pi is enough without Arduino.
Yes.
But are there any cases where Arduino is enough without Raspberry Pi?
Actually, I'll tell you one thing very interesting. I think a little more philosophical answer to this. So when I started this work, well, not exactly this one, the first one in 2003, I took in 2023, I took in advice from the colleagues from the IoT department, and they said that the difference between using Arduino and Raspberry Pi is like sending a single courier using a train or a plane. So like if you use Raspberry Pi, definitely it's like a small computer to do this work. But that is where I think I started thinking that no, I need Arduino, connect with the sensor, and then use Raspberry Pi to do the Python work for the blockchain. So yes, probably that was a start. But like now we have realized that I think we upgraded the camera module also. So this upgrade of the camera module will definitely work much better with Raspberry Pi than unnecessarily, in my opinion, to include Arduino in between.
But maybe with the help of account abstraction, it is possible to use some alternative cryptography, alternative to Ethereum's cryptography, and enable IoT devices signing something with Arduino.
Yes, so there is ESP32, if I'm not mistaken. It's called so there used to be, I never interacted with it, but definitely Arduino Nano ESP32, if I'm not mistaken, that was somehow and somewhere designed specifically for doing this work, but due to its availability and time constraint, I never looked at usage into it. Probably for future direction to consider using Arduino Nano ESP32 might be useful.
Thank you.
Yes.
There is a comment that yes, ESP32 is good choice.
Oh, thank you.
Smile.
Okay, yes. So yes, I was right that ESP32 it's called. Yeah, ESP32. I was right in recalling the name at least. So yeah, definitely I looked into it, but I think maybe somewhere knowledge constraint diverted me from not using it for some reason. I think so.
Okay, any other questions in web or in audience? If no, then let's think.
Thank you so much. You can use the presentation for this
Okay, we will share your presentation with the recording.
Yes.
And I guess there are contacts. If not, I will request your contact and share as well.
Thank you. Have a good